This demo will present noWorkflow integration with IPython and Jupyter Notebook. In the analysis demo, we presented noExport as a command to export Provenance as Prolog. However, noExport has an extra argument, -i, which generates Jupyter Notebook files for trials, diffs, and history. Thus, if we run noExport1-i, noWorkflow will generate the file trial-1.ipynb. We can open this file with Jupyter Notebook. In this file, the first cell loads noWorkflow extension for IPython, using %load_ext noWorkflow. Then, it imports noWorkflow.now.ipython as nib. This module will provide access to noWorkflow objects and functions on IPython. The second cell instantiates a trial object from nib module. Then, the third cell returns the trial object and Jupyter presents it as an activation graph. In this graph, nodes represent function activations. Their color represent their duration in a traffic light scale. Experiment.py represents the main script activation. We can follow the execution on this graph. The experiment.py first called a range. Then, it called read twice, in sequence. Then, it performed a loop with calls to sum and list.append. By the end, it called bar_graph, which called prepare, and savefig in sequence, then returned. This graph offers tooltips to visualize information regarding activations, such as duration and arguments. noWorkflow can also generate history notebooks by running noExport-i history. In this notebook, the second cell loads history object, and the third cell presents it. History nodes represent trials. We can use tooltips to visualize basic trial information. In this case, trial 3 finished successfully. However, trial 4 presented an error during execution. Finally, trial 5 was a backup trial. It was created because some changes were applied to the experiment script, but trial 1 was restored before its execution. After running trial 6, trial 5 was restored, and trial 7 was executed. Now, let's compare trial 1 and 7 using Notebook, by running noExport-i, diff:1:7. In this notebook, the second cell loads the diff object, and the third cell presents it. The diff combines nodes from both activation graphs, separating them with a line in the middle. Some nodes, such as read, do not have a line in the middle. These nodes appear only on one trial. In this case, read belongs to trial 7. It can be identified either by the first line on the tooltip, or by the node border color. Black border means it exists in both trials. Green border means it exists only on trial 7. Red border means it exists only on trial 1. The same color code is valid for arrows. While we do not have any nodes with red borders in this graph, we do have red arrows and green arrows to differentiate trial execution path. When we place the cursor over each side of a combined node, different tooltips will appear. Left side shows the tooltip from trial 1, and right side shows the tooltip from trial 7. This way, we can see that bar_graph received 2013, 2014 as parameter on trial 1, and 2012, 2013, 2014 as parameter on trial 7. We can use the diff object to access trial objects and compare their scripts. To do so, we have to load trial 1 as the first trial of the diff. Then, trial 7 as the second trial of the diff. We store their content as temporary files. Finally, we invoke Linux diff with the files to see added and removed lines. This video covers how to export Jupyter Notebook files and how to access noWorkflow objects. In the next video, we will present noWorkflow magics for IPython.